Hello, fine sir.
Lecture. Oh, I'm sorry, I'm in a lecture right now. No, it's okay. It's okay. I appreciate it. All right, guys, when you have a chance, go ahead and put in there what you guys came up with for the reasons why we care about joint alignment. Whenever you guys are ready. Nice. Okay. Nice. Chris's group, great job there. Marlana, I like the logic there. I wouldn't think of it so much as using the correct, but using the optimal muscles that are going to be able to produce probably a greater amount of force. And obviously other muscles might not have the same amount of force production capability, obviously not as optimal of essentially, length, tension relationships, and otherwise we're going to find in different positions. So we do want to make sure we're effectively getting where we need to be. Yes, great job there, Josh. And yes, Taylor, good point. And especially Josh, I like the second point, which is doing something with bad technique once is possible that it could end in a really, catastrophic injury otherwise. But typically people can get away with using bad technique for relatively long periods of time, but eventually it's going to get them. Eventually it's going to show up in some way or another because we've been using these compensatory patterns that are relying more on like ligamentous strength and tendinous strength. And eventually, because those tissues can only effectively repair from so much damage and only remodel at certain rates, we're literally going to get to a point where we're probably going to essentially damage something because it turns out we push those tissues further than what they were meant to tolerate. So, nice, guys, nice. Good work, good work. So, yeah, like anything else, our joints are meant to deal with forces in specific angles. So when we apply them in angles that we're arguably not used to, that's when we're talking about creating those shearing stresses. And those shearing stresses are going to be the ones that are potentially doing a greater amount of damage. So then the next question is obviously building off of the one that you guys just answered, which is, how does the body compensate for a lack of mobility in one movement? Think of it also along the lines of, one joint or limb in order to go ahead and obviously allow you to do a movement. Now, the other thing I would have you guys think of is try to give a movement example. So we're going to throw you guys back into those breakout rooms. It's 9:46. Plan on coming back at probably closer to, oh gosh, we'll give you guys another 5-6 minutes. Any questions, comments, concerns before we send you guys into those groups again? Awesome. All right, rooms are open. Go ahead, have fun. We'll see you guys back in a few moments. What did you guys come up with? Good. Now, Ethan, another thing to keep in mind, because I like your example with the shoulder, is especially if we've got somebody that's going overhead, if they don't have that range of motion, they might have to compensate by leaning back and having to use excessive lumbar curvature. Good job. Yeah, quite possibly, Josh, in that example, or they might have to round if there's a lack of mobility around, and that's even more dangerous. Yeah, potentially, Marlana, same type of argument, obviously only with the knee positioning. I like it. Yeah, everything we're doing when it comes to exercise is literally, it's nothing more than it's a problem that your nervous system is trying to solve, and it's trying to solve it using obviously your muscles, your tendons, your ligaments, your bones, etc. So the simple reality is, in these examples, you're trying to use tissues to solve organic problems by getting yourself to move where you need to move. Now, it's just using the tools that it has, and like anything else, without instruction, without good mobility, it's easy to do or to make less than optimal decisions with your movement patterns, simply because your body just knows it's got a heavy load on its back and it needs to somehow go down and back up with it. It doesn't know the reasons why. It just knows it needs to do it. And so it can make some major trade-offs for that good old healthy, or, the safety of a movement, simply because, well, we're just trying to perform it, not because we actually need it to survive or otherwise. Now, one thing, I don't have I shown you guys before any of the videos of Stefan Holm jumping? Okay, so we talk about the series elastic component. We talk about the parallel elastic component. So series being the tendon, the parallel being the elastic part of the muscle. And like anything else, it's all trainable to a certain extent. Stephen Holm was a really, really good high jumper. In fact, he's about 6 feet tall, to give you a concept of height of what you're about to see here, guys. And I guess we'll unmute it, not that it's going to make that big of a difference. Okay. Obviously, look how giant his legs are. Yeah. Okay. Now, like anything else, there are some, yeah, there you go, Axel. There are some major genetic components, but don't overlook the years and years of really hard training he's used to make sure that he has a powerful triple extension from his lower body, meaning he's getting plantar flexion from his gastrocnemius soleus, he's getting knee extension from his quadriceps, and then he's getting hip extension from his glutes and his hamstrings, and he's timing them up and getting maximal performance at the same time, and hence he can leap like a freak. The fact that he can do 5 or 6 hurdles in a row that are literally up to the height of the guy's chin is incredibly impressive for obvious reasons. And so, like anything else, when we talk about that elastic component, we talk about the once again parallel and series there. Well, yes, it is trainable, and if we've got better performance from each of those, congratulations, you are going to be able to in turn leap like a freak. And one thing to keep in mind is the limits we're going to have when we're doing movements based upon the different parts of our body. So one would go and, well, I'll draw a really bad picture because that's pretty much the only type of picture I draw. Okay. If we have somebody trying to do, I guess at this point it's a front squat, but they'd be falling backwards because my numbers are horrible. Okay. Now, they've got quads that can squat 500 pounds. Okay. They've got hamstrings that can squat 550 pounds. They've got glutes that can squat 475 pounds. And then they've got a low back that can squat 400 pounds. Okay. And they have an upper back that can squat 600 pounds. Okay. How much weight can this person squat? How much weight can this person squat? Yes. Why is it only 400 pounds? Absolutely, because we're going to be only as strong as that weakest link. Somewhere in the kinetic chain is going to effectively be the limiting factor. In this one, it's going to be the low back. Now, if we were to say the same thing about vertical jump, where we've got quads that can easily jump 30 inches, we've got glutes that can easily easily jump 31, hamstrings that can squat 30, and then calves that can jump 20. How high are we going to jump? So when you're working with an athlete, when we're looking at movement patterns and we're looking at potential faults and otherwise, yeah, we can have issues with stabilizers, which I'm not even talking about here, but we can obviously have issues with our main primary movers. So how many people do you see doing a lot of, really strong, aggressive calf training in the gym? Yeah. So like anything else, we're going to be limited by whatever that weakest link is. So when you're working with people, thinking about, okay, what's going to be the thing that's holding us back? What can we go ahead and develop? And this is where you can do muscle testing and otherwise, but usually you'll see where they compensate in the movements is either a technical fault or a straight up strength and, performance of those individual group fault. And if you see that, that's when we're going to go ahead and make sure we change up our programming to address those weak points. So now, guys, we're going to go ahead and talk about this last question right here, which is why do we care about pelvic floor musculature functioning? What happens if it's too lax? What happens if it becomes too tight? And I believe this is already up in the chat, but I'll put it up more recently so you guys don't have to look that far back in the past. It is 10 o'clock right now. We'll plan on you guys coming back at like 10:06, 10:07. So whenever you guys are ready, the breakout rooms are open again. Ethan, I will get you back reassigned and go ahead and hop back in when you guys are ready. See you guys back in a bit. But yeah, absolutely, guys. If it's too tight, we're talking about incontinence in one way or another. We can maybe even have a prolapse if it gets bad enough. It's important because effectively it's what's keeping our organs from dropping out the bottom. So we need to have a certain amount of integrity. And the bigger issues it's going to show is more or less people that are going to be peeing themselves when they're not wanting to, just because unfortunately their body is not able to, keep their, shall we say, fluids where they want them to be just because of the nature of the jostling movements. So, yeah, otherwise, you guys are all kind of hitting the nail on the head for what we're looking for there. And that effectively is all the things that I really wanted to make sure we reviewed for your final. Do we have any questions about your final paper or anything else that you guys would like me to go ahead and talk about right now?
I have a question.
Yeah, what's up?
So, I thought that the Hall Chapter 6 homework quizzes were due this week since the other quizzes are due this week.
Mm-hmm.
Is there a way I could still take it or no?
Mm-hmm.
Like, I had it in my planner that it was like do this week.
Yeah, no worries. Give me a little bit of time and I will do my best to go ahead and reopen that for you guys. But, you know, when in doubt, please try to stay on top of when obviously all the due dates are coming up.
Okay, thank you. I usually do. I just had it in my planner that was due this week for some reason.
It's okay. Welcome, welcome to the pandemic. It's been hard on all of us, in its own ways. So, okay, you guys feel how's the videos going along? You guys got all that wrapped up. You guys are obviously hopefully working on the math for your assignments.
I had another question.
Yeah, what's up?
So you said describe the muscle activated during the phases, like for the paper, and then you use a table. Do you mean like a table we use for the movement breakdowns?
Yeah, a table like that is probably going to make it the easiest to go ahead and read and see. And then instead of just having the muscle actions, you'd have another table that effectively you'll just have the joint action followed by this is the force being produced. This is the torque being produced. This is the velocity during that phase. This is the acceleration during that phase.
Okay. So you have to do, for each phase, you have to do that.
Yes, for each phase, you need to break it down that way. Mhm.
Okay. Okay, thanks.
No worries. Are there any other questions, comments, concerns you guys want to go ahead and touch upon?
Will we be having class next week? Because since the review's over, or
So for class next week on Tuesday, effectively, we are going to, I will be here to answer any questions or to help you guys review a bit further. But, you know, effectively, because we've gotten through all the material and I guess no one else really has any questions over things they want to cover. Plus, obviously, aside from going through the entire study guide, which, you know, you can find on obviously the, you know, the YouTube channel for the class where we go through every single question on there. Yeah, we would just it's kind of just to be here and help you guys work on your papers and we can kind of talk about that. So it's 100% optional. You do not need to show up for that.
okay, thank you.
No worries. So guys, is there anything else you guys want to talk about? Feel weird letting you guys out so early. Not that I'm sure you guys are going to mind too much.
On the last lab with where it said we had to have 2 force plates, since you said the forensic science lab had the other one, what are we going to do about that lab?
So you're going to be able to find a video of that on the YouTube channel. And so you're going to use that for your example there.
Okay, thank you.
No worries. Sorry about that, Josh. Actually, we could rig it. So the way that you would come in and do it is, since we're not going to be able to look at both sides of the body, we can just go and look at one side of the body. And so what you'll do is we'll have you put one foot on the force plate and then we'll have you standing on an equal height riser on the other, because you won't have to worry about looking at your left foot, your right foot. You'll just simply know what is your body weight on the force plate. And then you're just figuring out the total mass would be obviously how much you weighed there. And then you're subtracting how much you're going to have from that 1 foot on there. So you don't actually need both force plates for it. So yeah, if you guys still want to do that, you guys can obviously figure out a time that's going to work for you guys and then bring yourselves in the lab there accordingly. So any other questions, comments, concerns?
And I believe is our presentation due next Thursday?
Yes, your presentation is going to be due next Thursday, as is your paper.
Are we going to present that Thursday?
No. We are going to have you guys record a PowerPoint, and that's what you guys are going to submit to me with your slides narrated. Now, I'm going to go ahead and put up all of those videos, all of those PowerPoints into Blackboard so everybody else can watch everybody's presentations and give you guys feedback, but you do not need to give it in class.
Okay, yes, sir.
No worries. Well, guys, you guys have a great day. Stay safe out there. I'm going to keep trying to fix the wonderful lab gymware because the tether is not returning. And yeah, I will see you guys. If you choose to show up next Tuesday morning, it's not 100% necessary. And then, yes, so thank you for bringing up the lab part, Josh, as far as what we're looking for and making sure that you guys are getting both your individual paper and then your group's presentation. Remember, if one member of your group doesn't give you the materials by the time it's due, that's fine. Just put in a blank slide and put their name on it, and they will get the grade accordingly for not having done, obviously, their work. So, any other questions, comments, concerns? I guess not, because people are leaving. So, that being said, guys, stay safe out there, and I will see you guys next week if you choose to show. Okay? Bye-bye.